Hello everyone. Today we have with us one such amazing personality who is an inevitable part of IITM community. He holds a BTech in Mechanical Engineering from IITM and MS and PhD from Purdue University. Nirman, the pre-incubator of IITM, is his brainchild. Under Nirman, over 125 startups were nurtured and have gained entrepreneurship experience. He also launched a pan-India science and technology magazine, IITM Shastra, which features India's best science and technologies. Also, he served as the former director of IITM Incubation Cell. Currently, he is professor at Department of Applied Mechanics, IITM, and also Dean Alumni and Corporate Relations. It's my great privilege to welcome Dr. Mahesh V Panchagnula to share his experience about teaching and research to the entire research scholar community at IITM. Welcome, sir. Welcome to this year's Research Scholars Fest. The first question I would like to ask you is, what are the social outreach activities which you do along with the research?
Sure. Yeah. There is, letting the world know what we do as a researcher is the first duty of every researcher. Whether you are a student or a professor, you are not doing your research just to sort of understand things for yourself. That's only the first step. After you discover something, you want to communicate it to the whole world. That's why we write papers. That's why we go to conferences and talk to people. That's why we post our new and improved developments on social media. That is why, and part of that duty is to also tell the world why they should be doing research, why they should be interested in science, in technology, and what are some things that can happen as good that could come out of pursuing science and technology. So that is broadly what I call outreach. Outreach to young students to get them into science and technology, outreach to industry to inform them of what are all the exciting things that our students and research scholars at IIT Madras are doing, and also outreach to the alumni community in my current role as the Dean for Alumni and Corporate Relations to let them feel good about their alma mater. When you graduate and go out, when you hear, IIT Madras research scholars did these new and amazing things, you will feel good about IIT Madras. So these are the sort of broad outreach activities that we are part of.
So recently, we read about the new Center of Excellence for the Sports Science and Analytics, and that also has a big motto of societal outreach. So what do you have to say about that?
It's a very interesting center. India is a very sports passionate country. There are many different sports that are now coming on the horizon professionally. And we feel that at IIT Madras, having a very strong group working in machine learning, in AI, in data science, as well as mechanics, there is a lot we can bring in terms of rigor to sport. So we've been working with some key partners. We've been working with some of the IPL teams. We've been working with some of the Olympic training programs that India has to basically work on athletes' performance, to help improve athlete performance at the end of the day, or team performance, by giving them insights into what kinds of training they should be doing, what it is that others in the world are doing, and that we can bring to the table. For example, if you take a sport that has now caught our attention like Javelin Throw, Javelin is a mechanics problem. At the end of the day, you are throwing a rigid body, what you think is a rigid body, but it's got its own flexion to it, at some angle, with some velocity, and you want to maximize range. You have air drag, you have the vibration, fluid-induced vibrations of the body itself. And then you also have the athlete. The athlete is basically transferring force from the ground to the javelin. So this whole process is absolutely a mechanics problem, right? On top of this, if a javelin thrower throws 100 throws during practice and you get 100 different ranges. Now, from a mechanics perspective, using what is called a first principles approach, I can define what are all the factors that will get you the maximum range. Using a mechanics model, using a drag model from fluid dynamics, using other things. I can also look at this purely as a data science problem. and say, look, I have some n variables as my inputs and one range as my output. Can I correlate these two, the input variables to the output, in some way that I can give the athlete something prescriptive? And say, watch your, he's a right hand thrower, but watch the position of your left hand, for example. This seems to have an effect. So using a mixture of computer vision analysis and data analytics and mechanics, we want to bring a rich view to every sport that matters to Indians. And so we have some sports that we have sort of zeroed in on initially. We want to look at cricket. We want to look at sports that have been rather untouched by data science, like boxing, judo, wrestling. These are sports where India wins Olympic medals. Right now at the bronze and silver level, but we want to dominate. For us to dominate at that next level, we need this layer of technology that backs up an athlete and his or her coach, gives them something prescriptive to shoot for in the practice sessions so they can do better. This is roughly what our mission of our sports science center is, and we believe this is clearly it's got societal implications. When our country does well in Olympics, we feel good. It originally was Neeraj Chopra's individual effort with the system around him, but as Indians we all feel very proud that he won the gold medal at the last Olympics. We want that feeling to occur and recur many times over in people's minds. That is our mission. So in order to communicate we have an obligation to communicate our research, our science and technology output to everybody, to the Aam Aadmi, to the Aam Janta at large, because we are taking funding from them. So in order to enable this communication, we launched a pan-India magazine called Shastra. So this magazine, as you can see, is basically intended to communicate anything interesting happening anywhere in India to first Indians and then to the world at large. Okay. The stories come from all institutions in India, all research, science and technology institutions in India, startups. There's a lot of interesting things that are being done in India today. We just don't know because we have no platform for us to read and understand. So we are very excited about this, and we believe that this will make a difference to the way we perceive our own country's science and technology output in times to come. So that's part of the broader outreach. So the outreach is the first part, to tell the world what IIT Madras is doing, but to also create platforms where anybody can tell the world what IIT Madras or what their institute is doing. That is what Shastra is all about.
That's really great, sir. I mean, launching such a magazine which is of use to the common man, that is a really great initiative. So next question I would like to ask is, which is more satisfying for you? Doing the regular research or focusing more on these outreach activities? Which is more satisfying?
In some sense, both have their own space in what we do. Every one of us faculty members do a little bit of both, always. But I'm a professor first, so my research is obviously important. I cannot ignore that. Not just ignore that, that's the passion because of which we are all in this profession. Whereas the administrative roles that we don, whether it was as the director of the incubation cell or now as the dean, these are all roles we play to further the institute's mission in a particular slice of the puzzle. So we step into these roles, do our part, and go back to being a full-time researcher and professor. So we sort of double up while we are here without ignoring the first role, which is to be a researcher doing good science and communicating that good science for the world to read, appreciate, and use.
So out of many researches which you have done, you want to, something which is close to your heart, something which is you were very passionate about, you wanted to get it done, and you have done it, something you want to share about that?
Sure. There are many, we worked with almost over a dozen PhD students and several master's students in the past, and they've all done interesting work in their own right. Now, my own research is in the broad realm of multi-phase fluid mechanics, or even more generally, mechanics, because I've now started to look at sports as a mechanics problem. I think in this whole space, I'll say there are several interesting math problems that we solved along the way. For example, couple of my students worked on what we call the brachistochrone problem, which was a question that Johann Bernoulli posed about 400 years ago, where he asked the question, what is the shape of an inclined plane on which a particle takes the shortest time to go from a point A to a point B in a gravitational field? So if I have a point A and a point B, a straight line is not the shortest time path, it is the shortest distance path. As it turns out, a cycloid is the shortest time path. So we asked the question, what is the shape of an inclined surface on which a water bottle would roll in the fastest time? Because you now have the fluid dynamics as an added complexity. And we showed some very interesting results where, depending on the viscosity of the fluid, if it is either too viscous or too inviscid, the cycloid is a solution. But there is a sliver of viscosity range, so to say, I'm sort of translating it into a simplistic language. But there is a range of viscosities of a fluid for a given water bottle size where the shape is not a cycloid at all. So it is somewhat counterintuitive that for near zero viscosity and near infinity viscosity, the cycloid is actually the best, is actually the surface, but not somewhere in the middle. So this is one example of a problem that we worked on. A little more industry facing, we work very closely. Our research group works in the space of spray and atomization, which is a problem that is of relevance to the auto industry, to our defense industry. There's a lot of applications, and we've made quite a few contributions in that space, specifically with understanding variability from injector to injector and making injectors more reliable in a flight application, and also characterizing injector performance in a manner that I can relate to the actual combustion and the thrust generated. So this is sort of a little more of an industry facing side of our research. One of my students worked on understanding edible oils from a perspective of what makes certain oils edible and other oils non-edible. What physical properties? I know, there are obviously chemical toxicity properties, but what physical properties are different from edible to non-edible oils? And as it turns out, there is a process called emulsification, by which a drop of oil is broken down into tiny droplets. That process is much faster with edible oils than with non-edible oils. And so the choice of oils is somehow dependent on also, among other things, also on which ones are actually digestible. Emulsification is the first step to digestion. So this is another example of some work that we did some time ago in that space. There is also work we've done in Marangoni convection, where we've shown that drops are propelled in a somewhat of a counterintuitive, non-Brownian walk, so to say. We're very excited about the work in that space. So I think there's a lot of different threads, because we get students in our group from many different interest areas, and I like working with all of them in their interest area rather than letting them veer and focus in my interest area. So I learn a lot. Every time there's a new PhD thesis, I end up learning as much as the student did. So that's one of the perks of being a professor at an institution like this.
Thank you, sir. So what would be the greatest accomplishment or achievement in your career?
The most satisfying part of any professor's career is to see their students go on, do well for themselves, they are able to support a family, they are able to make contributions to society. And that has been the most satisfying part of my career. That I've had dozens of master's students and several PhD students. All of them are able to contribute to society. They're all sort of well trained because of the institution that we have here, and they're all thinking very progressively as to what is it that India needs, what is it that the world needs from me, what can I add, where can I add more value. And I believe that I end up learning something new every time I talk to one of the alumni who graduated out of my group as to what they are doing, different from what they did for their PhD. So these conversations are actually very satisfying. Because these are people you would have seen come in, you would have gotten through a comprehensive exam, they would have passed an interview, and then along the way they've learned many new things that they are now able to become a teacher in their own right. So that's very always satisfying.
So now we can ask Professor Mahesh some funny questions. So if not in STEM field, what career path you would have chosen? What other profession you would be?
Definitely I would have been a lawyer. I missed.
Okay. So why lawyer?
Law is a profession that uses the same logic that math uses in some way, and I like law a lot, because at the end of the day, what we do depends on the framework in which we operate.
How does your typical weekend
Well, typical weekend is 1 day of relaxation. So I do some reading for myself, but 1 day is practically work, 100% work. So, but I'm also a bit of a sports person, so I do play a lot in the evenings. Tennis is one of my favorite sports. I've played over a dozen sports with some interest over the last 15-20 years. So I like trying out new things. So that's my passion for the weekend.
How do you manage time, sir? I mean, balancing this, busy career life and come to the family. How do you balance time?
I think it's a matter for first prioritizing and giving importance to your own time first. I think if I say my time is extremely valuable, I'm not going to let somebody waste my time. That's the first step. So I tell my students, look, I work hard, and if anybody in my research group does not work as hard as me, you're wasting my time. Right? And so you try to convey this message not by words like this, but by your own actions. So that there's no substitute to working hard. Within the framework of that, you do have to optimize use of your time by setting what are priorities for yourself. As a student, I'll say your priority should be to focus on your research, getting things done, and learning new things. That is the main reason you are all here. So the more you focus on that objective during the 24 hours, right, the more you will find yourself to be more useful to society later on. This idea of being useful to society has a proxy marker. It is called salary. It is only a proxy, but the more useful you are to society, the greater your value, so to say, is, right? So the more you value your own time, the more you end up while you are here, spend all the time you can to learn as much as you can. You will not get an environment like this anywhere after you graduate. So the more you learn, the more valuable you will be to society later on. So that's kind of been my mantra as well, that I try to learn as much as I can during the day. I try to prioritize what I need to do, what is some immediate things to do, what are some long-term things to do. Focus on all of them within the same 24 hours, and try to make things happen.
Any advice you want to give the research scholars of IITM?
So I'll say, I want to tell all the research community at IITM that you are the backbone of this institute. You constitute the majority of our student population today. You constitute the majority of our alumni population today. And you constitute the future of IIT Madras. There's absolutely no doubt about that. India cannot grow into being a 5 trillion and then on to a 10 trillion economy without a strong R&D backbone that is completely indigenous. And you are the backbone of that future R&D economy that India is aspiring to become. Today, for example, some of the large companies, even large automotive companies, employ less than 100 PhDs in their payroll. Within the next 5 years, that will change significantly. The entire Indian industry will learn to embrace the value of indigenous research and development. And so you are the people that have to drive that. You will be part of that change. You will be a key contributor in that change. So be ready for that. Be ready, because you will have to become the R&D backbone of this country, not some 20-30 years from now, the next 5 years. So be ready for that change and aspire to be part of that change. When the change comes and sweeps you away, you are part of the wave. That's one way. But can you not make that wave happen? Can you sort of be more proactive, learn new things, and be ready to build, develop, and sort of innovate in a direction that India can? That's my single-minded thought to all of you.
Thank you so much, sir, for those inspiring words, and thank you for taking out your time and sharing your experience with us.